On this episode of the show, I have with me Greg Foster. He is co-founder and CTO at Graphite. We're going to be talking about code reviews and shipping faster. And a lot of this is going to be in the vein of talking about how AI fits into the picture, AI code generated products, code reviews. We're going to talk about the developer experience. We're going to talk about shifting left of engineering and what that really means. I think Greg has some examples there for us as well. And hopefully we'll get to a few other things. But Greg, I appreciate your time.
Thanks for having me, Amir.
Absolutely. Tell everyone what Graphite does before we get started.
Yeah, so the way we often describe it is that Graphite is code review for the age of AI, fancy marketing, but within that, fundamentally, we are everything an engineer needs to ship code changes fast and smoothly through the process. We live in a world where there's more PRs, more code changes than ever before, and Graphite is trying to give developers all the superpowers that have been invented often behind closed doors at the Facebooks and Googles of the world, give those to all developers on top of GitHub to create the PRs, stack them, find them in an inbox, give them great code reviews with AI assistance, and then merge them out to production without getting bottlenecked against each other. So yeah, so we're obsessed with helping engineers move quickly, but specifically helping those code changes move quickly. I think, we nowadays it's getting easier and easier to create them, but you still got to validate them. You still got to review them and ship them out the door.
Absolutely. I think it's a great topic. I actually just spoke to somebody who was mentioning it's gotten so easy to work through problems. Checking in code and getting it reviewed is a different. And I guess let's maybe start off. We'll start off with that because I literally just got off of a conversation regarding that, and it was top of my mind. But when we talk about those code reviews, and actually, let's just talk about that code reviews and where that sits within a developer's workflow. Maybe that's a good starting point.
So from a high level, and maybe many engineers are kind of familiar with this, but pretty much everyone has to do code review. Any modern software engineering company, you pretty much have to do code review. You have to do it because it's best practice. You got to do it because it's cultural norms. It's also often bound in regulation, or compliance. SOC 2 and anything beyond that is going to necessitate code review. This hasn't always existed. I think this came about in the 70s. Originally, it was engineers poring over printed out pieces of paper of code, really staring for bugs. And that kind of evolved into desk checks where someone would come by your desk and look over those code changes. And I think where it started really taking flight in the 2000s and beyond, you have Git and GitHub and these open source patterns where someone would create a pull request. But what is a pull request? It's you asking a maintainer, a stranger online, hey, please merge in my untrusted changes, and that maintainer is going to review the request to pull those changes in. So you're really starting to get this a very firm pattern of code review. And I think as companies lean into these open source patterns, they really lean in also to the best practices of code review. And the same thing, whether open source or closed source, you have folks reading these code changes. They're also testing it. They're also running lots of validation, linting, unit tests, you name it. And then at some point, clicking a big green merge button and merging it in. They realize there's issues with that too, so they start building merge queues on top of this. But yeah, it's kind of evolved over the years. And then now we live in a world where it's kind of even more important. I didn't really expect this when we started Graphite, but now sometimes these code changes were never read by a human in the first place. You used to be able to assume that at least an author read it, and hopefully the author's not malicious, but at least an author read it when they wrote it. And they're with best intent trying to merge in, you're trying to get a second pair of eyes. Now, sometimes you're getting a first pair of eyes on these code reviews because Devin or Codex or Claude Code in YOLO mode was creating this code change and the engineer just shipped it out. So the importance of that step in the process of validating and reviewing the code is kind of can't be understated at this point.
Absolutely. This crude example, but you still find shirts where you'll open it and it has a little tag and inspected by number 12 or whatever. Mm-hmm. Where is that going to be within software development, right? Because I'm sitting here going, the easier it is to produce things at scale, mm-hmm. the harder it is to sample and check for what is considered right. And in this case, where a lot of code is being generated and more code will be generated by AI, where does our inspected by number 12 fit into this picture?
Yeah. So I think to answer that question, we got to break down what's the point of code review. So on a shallow level, and as I just was talking about the history of this, it did start from this place of let's try and find the bugs. That was kind of an origin of code review. But I think in many ways, again, even before AI was getting popular, that was already less and less of a core goal of code review. If the bug is being caught only because a second pair of eyes closely read the code, already something's going wrong. Yes. Hopefully you have continuous testing. Hopefully the author in the first place was catching that. You're actually starting to go on other things. You're sharing context among the different engineers in the team so they can understand what's going on. You're hopefully having a good discussion around the architectural direction of where this code base is going. Hopefully you're starting to have debates around the subjective parts of it. And you're also reflecting and bringing in context that the author might not have known. Maybe there's a meeting, maybe there's a design doc they didn't know, and you're having those conversations. So I think about all these different aspects of code review. And what you kind of start getting to is you realize that the PR page is the center node of collaboration fundamentally between different engineers. If they're open source and working remote, the PR is where they're talking. There's like these forums of debate and discussion happening. Internally at companies, people are linking a PR when they're discussing, should we go in this direction? Like it's the point of collaboration. So you ask, like, how is that kind of evolving with AI? I think the bugs part of it will get less and less. I really do, because yes, AI sometimes makes mistakes today. Claude Code and some of these tools make mistakes today. But you give me one or two more model jumps, I don't think they're going to be making a lot of mistakes. They're not going to be making common bugs. They can also write unit tests, and they can run those unit tests. I think more and more that will diminish. And the importance of that code review is not like the logical correctness of that very specific change in that diff. It's going to be, how is this cohesive with the vision of what we're trying to accomplish? What's the context the engineer knows of, like, what problem are we trying to solve? Where are we trying to go with this? And also just maintaining context of how the whole thing is changing. That's the important bit. And having that discussion, even if the person on the other side of the table is an AI agent and you're discussing it with them on the code change, that's how humans work together today. Is you go back and forth on the PR page. I think that's how they're going to work together in the future. So weird times, though. It's weird times to be doing code review.
Absolutely. You mentioned, obviously the PR, component, and people will be kind of at that little meeting spot to understand what's happening, what's transpired. Code quality will improve. The human obviously still has a role to play. I firmly believe we're engineers are going to be as valuable as they ever were. I think real expertise is in the hands of those that can ask the right questions. And if we're going to see more code generated, more code being reviewed, and we're going to see less bugs, which all makes sense. When it comes to having that historical context, when developers going to have to step in, right, and look at an issue, we've historically seen when somebody joins a new team, there's a ramp up period to understanding what the code base. You always hear, I need to understand the code base before I can really contribute. I need a little bit of ramp up time. You're going to have people that are not necessarily writing this code, not necessarily navigating where the code has been, where it's going. Does that represent a challenge if a human does have to slip in and try to address an issue, or are we going to have a different infrastructure around that to make that easier?
I was actually just thinking about this the other day. I think this is an emergent problem that's not getting a lot of discussion, but it's gonna get more and more discussion. The easiest way to feel this today is one of two ways. One, go be a manager and try and review code on a team. And after 6 months or 12 months, you're like, oh my God, I didn't write any of this. And you're trying to be thoughtful and you're trying to give feedback and advice and see where it's going, but you're realizing you're losing touch with what's going on. That feeling. The other way to feel this feeling is go create a side project in Claude Code, let it rip for 30 minutes, and then take the next incremental change and try and thoughtfully review it. And you'll be, what you just stated, you'll be like, oh my gosh, I'm missing the broader context. I'm trying to give feedback and reason about this, but I'm like losing track of the broader context. So the emergent problem is, if you're not writing it, we used to take for granted, we used to get for free the absorption of context. The same thing we're all obsessing about with AI, like how do we get AI more context? How do we get the human and how do we get the engineer the context? Because we used to get it for free. If you just sat in the code base, you fixed bugs, if you refactored some stuff, you ramp up an engineer. What are you ramping up an engineer? You're like giving them many small tasks, partly so they can just sit there and absorb the context. And we believe it's really valuable. I think that we'll have to reflect and find new patterns and ways for engineers to absorb and maintain context if they're not writing as much of the code. And code review is part of that, but I'm not sure it's enough. I mean, to your point, I'm not sure it's enough, because by the time you're doing really important high stakes code review, you kind of already need some context. So it's a way to help maintain it, but I don't think it alone builds the context. Whether it's new patterns of like code walkthroughs and reading, whether like we're all going to in the future, we'll all spend an hour a day just like asking the code base questions and getting summaries of recent changes and just like debating the architecture. I'm not sure what the best practices are, but I think because we're losing something that we used to get for free, there's going to have to be a new emergent practice to maintain that context.
100%. I speak to a lot of people. I know your business is within the space. You speak to a lot of people. It's the one thing I have not heard enough conversation around. So I had it in my notes to ask you if I had an opportunity, because I actually am looking at this going, that's why I joked about the Inspector 12 question of things being sampled. It's very easy to pick up a shirt, look at it and go, was it cut right, sewn right? Is there any defects? Okay, we assume that batch, because they cut all the shirts within one press. I mean, anyways, but it's easy. But within thousands of lines of code, if something goes wrong, it's already hard, even if you wrote it, to know what to fix if you didn't write it. And I think it's interesting because that's the way we've done things. So the habit says, I need to also understand the code base. Okay, we're going to get tools maybe that help us navigate that. Okay. When it comes to the developer experience, I mean, engineers go into this for understanding a problem. They enjoy the art of coding. To me, it's a foreign language, just like any other spoken language. It's got its own context and syntax and all that type of stuff. Does the developer experience change? And well, maybe let's start with that question before I ask you part two of that.
Does the developer experience change with regards to just the emergence of these new tools and patterns and problem statements that we're discussing?
Yeah, absolutely. Having assistance of doing what you might have gotten into the field to do, what you enjoyed. Yeah. That's being a little bit removed from you potentially.
I think so. I think that we'll spend more time, one, what we just discussed, trying to maintain context in novel ways, but also shepherding these code changes. If the code changes are really rapid and cheap to create, I think we'll just see a shift in the percentage of our time that we spend ushering those code changes through the process. Because already today, even again, without AI, only like half the engineer's job, if we're lucky, is hands-on keyboard, deep in flow, writing that code. So much of that is still getting it to pass CI, double checking, in a design doc review that this feels right to your teammates, merging it, but also merging it and then like deploying to staging, watching the graphs, getting paged for an incident, then like panicked and rolling back. There's so much that we do as an engineer and people have called this DevOps or different names for this stuff. And that a lot of those things I don't think are immediately solved by LLMs. Now we can imagine new tools that make it a little nicer, but a lot of that stuff is not immediately solved here, even if the code changes are really quick to write. So I think we'll spend more of our time helping implement, integrate, roll these things out to users, and then reasoning about, okay, what are we going to do next within all that loop? And I'm actually very okay with that as an engineer, because when I think about engineer, I'm not like, okay, I was put on this earth to just type a lot of code. I was put on this earth as an engineer to solve problems and to invent stuff and bring it to users. Coding is just a means to make some of that stuff happen, but I don't write assembly, and I don't have to write TypeScript, someone else can do it. So I do see that pattern evolving. Maybe it's a lot more prompting. Maybe it's a lot more code review. Another way I think in the interim here, because this is all a spectrum of how quickly we get to some of these end games, but I think that I'm realizing recently more and more that stacking workflows, and we build that, but you can use stacking without Graphite too, but stacking workflows I think are going to become a lot more common in the near future. And the reason is because large pull requests and large code changes still suck. They suck as much as they've ever sucked. They're still bad. AI didn't make that better. They're still hard to review. They're still hard to like debug CI. And if you have to roll them back, it's still a pain. So you still want a lot of small code changes. What changed, and the value of stacking your code changes is that you don't get blocked as an engineer. You can create a PR, and while it's getting reviewed and tested, you can just create your next PR on top of that. Well, now creating the PR is really fast. So who wants the stack? Well, Claude Code wants the stack and needs the stack more than anything else in existence. Because if you're just sitting there vibe coding and letting it rip and producing all this stuff, you don't want to just put up a 5,000 line PR. It's going to get a terrible review. It's going to car crash in production. You now, every 2 minutes, want to save a checkpoint and create a stack and tell a story with those small code changes. and then get them reviewed in parallel and then merge them in a batch as you want. But what we're seeing is a lot of the really kind of advanced users of these tools are also combining it with stacking and really benefiting from the parallelization and unblocking. So Stack's been around. It's been around for 10 plus years, but I think that it's going to get supercharged by the advent of these agentic coders.
I'm going to ask you a left field question because I don't want to derail the topic, but I am curious now that we're talking about this. When it comes to tech debt, obviously code is expensive to produce. Number one, we value it. There's a certain amount we're willing to carry the cost of code to amend, fix, repair, update, all those different things. Everything you've said thus far to me sounds, the episode's about shipping faster, making automated AI solutions to write code, review code. Is there maybe a world in which we're going to view tech debt differently? Are we going to potentially this one's maybe we'll go out further, 5 years, look at this and go, code's disposable. I mean, we don't even worry about tech debt because if something changes, it's much cheaper to code something from scratch than worrying about maintaining or updating or et cetera, et cetera.
Super interesting question. I like it. I mean, to answer that, I got to figure out, what is tech debt? I mean, we kind of know the feeling of what tech debt is, but what is it really? One of my teammates, I think he was quoting a book, said that tech debt is any code that doesn't have tests on it or is already legacy code. Yeah. It could be code that was good enough at the time, but can't easily be changed to handle the new constraints and requirements of the situation that we have. Could just be an outdated version that's now been deprecated because it's no longer supported, and you got to update it, or like your CPU will stop running. So there's these different stories. You have the famous story, I think, from Amazon that they upgraded their Java to a new version of Java using their internal AI LLMs, and it saved them some inordinate marketing number of hours of engineering. So I don't know. I think about these different forms of tech debt. If I was to maybe interrogate those three examples, code that's not tested. Well, it's gotten a lot easier now to write tests. So I do think on one level that test, comment, documentation, a lot of this stuff that helps prevent or helps aid in the defense against tech debt is getting a lot better and a lot easier through the advance of AI. That's pretty nice. When it comes to just upgrading a system, essentially, what are we really talking about? We're talking about really large-scale code mods. We're talking about moving from a monorepo that's now deprecated to a polyrepo world, or back from microservice architecture back to monolithic architecture, or to Java newest version. These are forms of tech debt and migrations that people hate. Maybe that's a lot easier to execute now too. But one other, the third level of how just is the old system that we designed really hard to change and evolve to the new system. That one I think about is the best way to cure that is really clean architecture. It's the standard practices that have been tried and true for the entire duration of software engineering. How do you choose to modularize? Do you use composition? Do you invert dependencies so that your core business logic doesn't have to change when your dependencies change? These are classic, timeless architectural wisdoms, and those don't really seem to change. Good architecture is still useful in the new world. It's useful in the old world. I don't think the question would be very interesting if it got so easy to create throwaway code that you don't even have to worry about good architecture. You can just spawn a new system as the constraints change. I'm a little suspicious. I think the pathway that we'll sooner take is that the AI will know the good architecture principles better than we respect them ourselves. It'll write that, and we'll be able to handle the incremental changes as we go along. But maybe, you see this in manufacturing. It's just print a new one, throw it away, 3D print this, throw it away, stuff like that. Do we get very disposable with all this stuff? It's not. If you told me it happened, it'd be interesting. But I think the incremental path, and maybe that therefore, because the incremental path, it'll be the local optimization where we land in, will be the AI will write cleaner architecture than we do ourselves. Yeah,
I 100%. I could definitely see that. I could definitely see. You said early on in the conversation, the human in the loop. The AI you might actually just be talking to the AI, understanding those changes, where they are, what's changing the business, giving it the feedback as to some context has changed in the business, and it goes in because it has written more efficient code architecture. It will make the change, and the change isn't going to take because it knows all the code base. Because obviously, in a team, I'm thinking of going, well, if there's 20 of us, you've written some of the code, I've written some of the code. When somebody wants to change it and we're all not there, that is just a cluster of people trying to figure out changing the code. I mean, we've all been there. And I look at this and I go, it's very interesting because you are bringing efficiency to areas because humans are inefficient, not because we couldn't write better code or we couldn't maintain it. I mean, there's only so much budget. You can't keep going backwards. But I do think that we talked about, obviously, shifting developers to the left. And I think some of what we're talking about is the human not writing the code. You didn't grow up saying, I want to type all day. You want to solve problems. And that shifting of engineering left and focusing on more of those problem solving skills, more of the asking the right question, which I think is a lot more art than science sometimes. You mentioned that shifting left, and obviously we might maybe share an image of this. I don't know if we will or will not, but I know we talked about this, and you mentioned that there are certain components of engineering that we've talked about that are shrinking, and there's certain skills and features that are going to be expanding. I kind of love to maybe have you dive into that, and I know without the image, you're going to be explaining a little bit more.
Sure. I think about software engineering really in these two large components. I think formally, if you were to Google it, it'd be the inner loop of development and the outer loop of development. Inner loop is I'm opening up my IDE or my Vim or whatever, and I'm writing a code change and I'm saving it. That's the inner loop. And that's a whole art form and a journey. But once I've created that code change, there's now an outer loop of software development. How do I get that from that change I just created out there to running on production servers? And it's a process of creating a pull request, picking reviewers, executing tests across it, making sure I'm passing everything and I get a stamp, hitting a merge button. But even at any large company, once you hit the merge button, you're not done. That still needs to go through a queue, maybe multiple environments, be validated, have real traffic run against it, monitored, and finally maybe feature flagged on or off. And then finally, a week later, maybe you can dust your hands and call that change landed. I think people could talk about code complete versus actually released. Big differences, right? So I do think that we'll just experience, if nothing changed, we would experience a huge bottleneck on that outer loop of development. It's the inner loop shrinking. We're spending less time there. The outer loop now needs to handle a lot higher throughput than we ever demanded of it before. In order to really reap that acceleration, we got to keep changes moving really fast. But humans aren't reviewing code by default faster. The CI isn't running faster by default. Merge queues aren't getting faster by default. So there's room for innovation in these practices and in the tooling here. Can AI give an early pre-review? Can we coordinate the CI a little faster? Can we batch things in stacks to merge them in a little bit faster? What innovations can we layer on top here to keep the throughput really high? And luckily, once again, as true almost always in dev tools, we don't have to reinvent the wheel from scratch. Like there's companies like Google who have some of the fastest mono repos in the world, fastest shipping code changes and throughput in the world. We can take some of the lessons and innovations from them and then bring those patterns to everyone else who doesn't work at those kind of companies. So I'm okay with this. I'm okay if this is the future of software engineering and how we build things. If I was an engineer in the physical world, it's okay if I didn't create the wood from scratch and someone just hands me a wood panel, but I'm still building a building. There's different levels and abstractions of components of all this stuff. And I do see this kind of as a natural evolution there. You have nerd sniped me with the question of, will we just 3D print a new code base every single code change rather than try to incrementally develop it? I get afraid of that. I think it matters that it's not a complete black box system. In that world, my God, every new code change is a whole new black box. And if there's a minor hallucination, it's going to be tough. How do I know it's right or not? That's kind of the hardest question. How do you maintain context? How do you know if this code change you didn't create is right or not? There's a really famous old saying, which is that the computer can never be held accountable. I think this really matters. If we work at Tesla, you and I, and we, AI code gen a thing and AI review it and merge it out and a car crashes, like that's really bad. That's really bad. Who's the AI that's not accountable? We're accountable. We're the engineers. So how do we maintain that accountability, the systems we're creating, maintain that context? This is the challenge. Today, I think it's the extra important to do the code review. Tomorrow, I think we're going to have to keep innovating and iterating on these practices to keep up with the volume.
I actually agree with you. Everything we've talked about, I'm not sure how quickly, how fast context will be. I think that I agree with you. I think the biggest gap for all the discussion, I actually think code review, AI generated and looking through for the low-hanging issues, the issues that we typically don't see, or optimizes us to do something. I think all those make sense. I guess maybe final question for you, and I just want to just get your take, because I don't think there's a right or wrong answer to this. But you use the example of Tesla. When I post out my content, I get all kinds of messages that the AI can't be trusted. You know, whatever the system is, I get the same comment, and I go back the same. I go, it is interesting that we have to hold the AI, the machine, the code to a higher standard than humans. Humans are very error prone. I'm sure if we were to have AI code review a lot of code bases out there, we'd see a lot of issues that just passed tests, passed CI, all those things that got into production, no problem. But when it comes to Tesla, you know, we've seen the examples of the collisions, the issues, code. I recently had an episode around 911 systems and AI. I have this feeling that people want to hold these systems accountable to a higher standard than humans. And I don't know if it's because we just are afraid of them, or we don't know who to blame if it is a problem with the AI, because if it's another human, we can charge them with a crime, we could fire them, we could have judge, jury. I mean, all those things. I guess your thoughts of the standard at which we are holding potential AI solutions, and we'll obviously keep it boxed to developer tools, because I don't want you to have to worry about the other questions. But I am curious your thoughts there.
I totally agree. You just said, what are some of the suspicions? It's the fear of the unknown, something new. It's the accountability problem. You mean, to narrow it to classic problems we deal with developers, think about security holes and security issues. If you let through an IDOR or SQL injection or something like that, okay, are you the engineer accountable, or is it Cloud Code plus the AI code review system and that is accountable? What are you going to do? You're going to stop using Anthropic? Are you going to sue Anthropic? You can't probably do that. And your users are probably demanding a little bit more accountability of the engineers creating it. So I do think there's a meaningful accountability problem within this. And to your point, maybe it is that we just it's not until there's a 10x improvement that we can say, hey, we're willing to take the hit on the accountability and blame it on the computer, or blame it on the other company of engineers before we'll take our hands off that wheel. It is challenging. The bar is higher. That's why I really think for a while, when it comes to code reviews, and we build Diamond, and probably the best AI code reviewer right now, it'll leave comments, it'll leave a pre-review, but we're the creators, and I'm not here to say that I don't think it's going to replace humans anytime soon. I think a human still needs to give that final stamp, because it's more than just the diff, also the context, but it's the broader, is this where we want to take the product? Is it okay if this fails? The other thing, when it comes to security, man, these AI LLMs are very gullible. I could very easily imagine a prompt injection attack on a code change using a couple of comments that would really let the AI code review allow through my vulnerability. Whereas a human would read that and immediately be suspicious. But these LLMs are quite gullible, it seems. So even for security alone, I really think that this is going to be quite unsolved. And maybe you kind of see this today too. Now, luckily, people aren't too evil when it comes to Waymos and Teslas, but you can trick them. They're not too hard to trick. And we know that in software, the world is an evil place. People are constantly trying to hack and inject and attack these systems. So it's got to be really, really good before you're defended against all those cases. So perhaps even in that case, because the world is extra malicious on the internet and so on, it's possible that the bar will be even higher than it is for some of these systems like cars.
Yeah, I agree with you 100%. I think engineers are not going anywhere. You see it all over social media, going to be replaced. Why go get a CS degree? I'm like, listen, it's going to be a very long time. And I actually have had a number of security people on recently about attack surface area. And when they talk about, you mentioned code injection, the attack surface area and the new challenges that engineers will have to make sure efficient systems are being released, I don't even think we've even begun to understand those new problems to solve. And I feel like it's going to be an evolution of the role. Can I guarantee you, if we took an engineer from 40 years ago, they would describe a whole different world of coding that would sound nearly fantastically AI-like to them if we did. So I do find all this very amusing. I think all your views have been fantastic, and obviously you guys are at the forefront of developing, on the peer review side and making headway. If we spurred more questions than we actually answered, which might be possible, or if somebody wants to just learn more from a follow-up question or about the product, because I think obviously kind of fits in the context, what are some ways of connecting with you, learning about the product, all those things?
Absolutely. I mean, check us out. It's free to try. Try out Graphite, graphite.dev. Feel free to shoot me a message on LinkedIn or an email, greg@graphite.dev. And just follow us on LinkedIn and Twitter, where we're constantly posting updates about what we're building. It's easy to use. You don't have to migrate off GitHub. You can just try it out, which I think is critical for any dev tool. I think you gotta create something that people can just kick the tires on and try. And we love it. We get to be collaborative with the best engineers in the world. We're figuring out in real time. Our users are these amazing companies who they themselves are using and creating AI tools. And we're just sitting with them side by side, trying to figure out how do we keep evolving the best practices here. So it's my dream job. Give it a check out.
Okay. Awesome, Greg. I appreciate your time. Thanks for coming on. Thanks for sharing with us.
Thanks for having me.
Absolutely. All right. That's it for the episode. I'll be back again. Different guest, different topic. Until then, two things. One, Greg walked us through a lot of different facets of where AI sits within code reviews, code generation. We talked about the developer experience. We talked about the shifting of the role of an engineer. I mean, we covered a lot of ground here. So send this episode, share this episode with somebody else who is in engineering, likes engineering. I think there's a lot of value to be found. So please do that. Also like, subscribe, comment. Let me know how the show's going for you. Until next time, thank you and goodbye.